Part 1 of Section 6.4 looked at making branching statements that used compound expressions. Let's continue the look at this section by translating high-level loops to assembly language. Now you might be saying, hey, I already know how to use a loop in assembly, and I sure won't argue with you about that, but the loop instruction turns out to be pretty limited. For one, it's tied to the ECX register. What if you needed that register for something else? Second thing, it can only count down from some initial value back to 0. Third, it won't allow you to test for a condition to decide whether or not to stop the loop. There's probably more that I just can't think of, but you get the picture. So let's see what it takes to create your own while loops and for loops. Let's start with a typical while loop. In some while loops, we first initialize a variable to make sure we get into the loop. The while loop itself acts sort of like a gatekeeper. If its condition's not met, then it won't allow entrance into the loop. You could say that a while loop is like an if statement that can repeat. Here, we're using x to control the loop. That means inside the loop, x has to change somehow. In this case, it has to increase. Otherwise, the loop would become infinite. Once x becomes 10, the loop stops and jumps to the statements following the loop. It's important to know that the loop checks the condition before doing anything else. Now, in this example, the condition is simple. But as you know, the condition could become really complex, combining ands and ors and nots, just like we did with if statements. Let's see how we can translate this loop to assembly language. One way to write while loops in assembly language is to sketch them out in a high-level language and then just translate them. That's the approach I'm going to take here in this video. Here's what that means. First, we have to initialize x to 0. Next, since the while loop checks the condition at the top, let's mark that spot with a label. At that point, we're going to do our comparison to see if x meets the condition of the loop. Said another way, we'll check to see if x is less than 10. If it's above or equal to 10, then the while loop won't admit entrance, and so we jump to the statements following the loop. This is another example of saying, what do I want to do if the condition's not met? If x is less than 10, then we don't take the jump, but instead we execute the code in the loop body. Somewhere in the loop body, we have to change x to make sure the loop is not infinite. To match our example code, we're incrementing x. Right after that, we jump back to the top of the loop so we can check the condition again. Take one more look at where the condition's being checked. For a while loop, it's always at the top of the loop. You know what? This makes me curious to see how a do-while loop would work. Of course, the main difference between a while loop and a do-while loop is where the condition is checked. The while loop checks at the top, and the do-while loop checks at the bottom. Another way of saying this is that the do-while loop always executes at least once because it doesn't even bother to check the condition until after it's already executed. In this example, let's assume the user is going to enter some value in a function being called from inside of this loop. Now here is definitely an example where we couldn't just use the loop instruction because this loop might run once or it might run 1,000 times because it's going to keep running until the user enters a non-negative number. Now let's look at the assembly language version. We begin with a label to mark the top of the loop so that we'll have a spot to jump back to if the loop repeats. We don't bother to check the condition here, we're just getting into the body of the loop. But somewhere in the loop, we're going to make a call to the getValue function. Since we're treating x as a signed integer, in other words, a double word, we're going to assume the getValue function uses the normal protocol to return its value in the EAX register. That's going to let us copy the return value into x. It's at this point that we check to see if x is negative. One way is to compare x to 0, which lets me jump back to the top if x is less than 0. Here's something to take note of. If I don't take that jump, then the program just goes on to the statements that follow the loop. You could say the code just sort of falls through to the next instructions. And once again, let me point out that we're checking the condition at the bottom of the loop. Okay, now it's time to take a look at the for loop. In the years that I've taught beginning programming, the loop that seemed to give people the most trouble was the for loop. Some beginning programmers avoid it like it was the plague. So I think it's worth just a moment of our time to go through how a for loop really works, because I don't want these throwing you for a loop. Here's a basic flow chart for a for loop. Let's see how it matches up to some code. The for loop really has 4 parts. The first part is the initialization of whatever variable or variables that will control the loop. In this example, we're just using one variable x. An important thing to notice is that this initialization part occurs only once. So in our example loop, we're starting the counter x with a value of 0. The second part is where a condition gets tested, just like with a while loop. And just like with a while loop, this condition is tested at the top of the loop. That means before the body of the loop gets executed. So you could have a for loop that doesn't even run once if that condition is not met. If the condition is met, then the body of the loop gets executed. That's the third part. And the fourth part is where the variable gets updated. You can add some number to it or subtract some number from it or something else to change it, but the point is it does get changed. In our example, we're just adding 1 to the counter each time. Then the loop goes back to the second part to check the condition again. If that condition is still true, the loop executes again. Here our condition is that x is still less than 100. So we know that as soon as x does become 100, this loop will stop and go to the statements following the body of the loop. So now let's take a look at a simple for loop. Okay, this one's about as simple as a for loop can get. We're initializing our loop counter to 25. Then we check for the condition, which is asking, is x at least 10 at this point? If x is 10 or bigger, the condition is met and the body of the loop executes. If the condition is not met, then the loop jumps to the statements following the loop. Now you know we're going to have to translate this to assembly, so let's do that. Let's go through the 4 parts. First, initialize the counter to 25. Then, like with the while loop, we're going to put a label to mark the top of the loop. Second part, we do the comparison. That is, we check the condition. Here, we're checking to see if x is at least as big as 10. Now, if it's lower than 10, we jump out of the loop to the statements that follow. The third part occurs if we don't make that jump. That means we execute the body of the loop. The fourth part happens when we update the counter. In this example, we're adding 1 to it. Afterwards, we jump back to the top of the loop to check the condition again. Y'all, this is a really flexible loop. Here, we could initialize the counter to any value we want. Here, we can check for whatever condition we want. And finally, we can update the counter in a variety of ways. We don't just have to add 1 or subtract 1. So there you have it, all 3 loops that are available in the high-level languages that we're used to using. I believe that if you go over this and spend some time with it, you'll see that it's pretty easy to translate those high-level loops into assembly language. All it takes is some practice, and I promise I'll see if I can help you out with that. But think about this. Now your programs can make decisions and repeat blocks of code. That's some really powerful stuff. Thanks for watching.